Hello everyone, this is Salama and Hind alhusseini from Princess Sumaia University for Technology. We are going to solve a problem about stability gain circles and constant gain circles. Stability circles depend on two factors, delta and k. If delta less than 1 and k less than 1, the system will be unconditionally stable. If delta is less than 1 and k greater than 1, the system will be conditionally stable. If delta greater than 1, the system will be unstable. Problem to solve. Plot the 2, 1, 0, minus 1 dB input and output constant gain circles for MOSFET with the following parameters. This is our S parameters from S11 to S22. Then find the load impedance for the maximum power gain and source impedance for maximum output power. Now we are going to use MATLAB calculator done by BSUT students to calculate the center and radius for stability circle. We put our S parameters here, S11, S12, S21 and S22 with its phases. We are going to click here at stability circle to calculate the radius and magnitude. Radius at source is 0, magnitude will be 1.41 and the phase will be 155, which is conjugate to S11 parameters. And radius at the load will be 0 and the magnitude will be 1.96 and the phase is 20, which is conjugate to S22 parameters. As we see, the center of the stability circle is greater than 1, which will be located out of Smith chart, and the radius equals 0, so no intersection between the stability circle and Smith chart. And now we will solve for constant gain circle, but first we need to calculate the maximum power gain for the source and the load. For the source, the maximum power gain is 3 dB and for the load will be 1.3 dB. And now for constant gain circle at 2 dB, the radius equal 0.254 and the center equal 0.625 at 155 phase. Now we will use Kitab program which done by BSUT student to draw the circles. From tools, we get the ruler and draw a line from the center to 155 phase. And now we will get a pen and draw the line. At this line, the center of input constant gain circle will be located, and we'll draw a line from the center to 20 phase degree, and this line, and at this line the center of output constant gain circle will be located. We will get a pen and draw the line at 20-degree phase. Now we go to tools and get the compass and going to reflection coefficient scale at the Smith chart and open it at 0.625. Now we will back to the center of, now we get the 0.625. Now we will back to the center of the Smith chart and draw an arc to intersect the line which will be the center of 2 dB circle. We draw the arc now, and now we go back to reflection coefficient scale and open it at 0.254, which will be the center of, which is the radius we calculate before. Now we are going to the arc and draw the circle of 2 dB. Now we will go back to the calculator and calculate the radius and the center of 1, 0 and minus 1 dB. We put the 1 and get the values, 0 get these values, and we put minus 1 and get these values. We will go back now to the Smith chart, and this is our final result at the source. And now we will go back to the calculator to get the radius and the center of 1 dB constant gain circle at the load. And we started from 1 dB because the maximum power gain equal 1.3 dB. The radius here is 0.107 and the center equal 0.454. Now we will go back to the Smith chart and get the compass and going to the reflection coefficient scale and open it at 0.107 to and open it at 0.454 to draw the intersection with the line we drew it before at 20 degree. Now we will go back to the center and we change the color to the red because this is the load. Now we draw the intersection with the line. And now we will go back to the reflection coefficient scale and open it at 0.107, which will be the radius of the 1 dB circle at the load, going back to the intersection, which will be our center, and draw the circle. Now we will go back to the calculator and calculate the radius and the center of 0 and minus 1 dB. The 0 is these values and we put minus 1 here and click here to get these values of radius and center. Now this is our final result on the Smith chart. And now for the circuit to be matched at the maximum power gain, we choose the path from the load, constant gain circle at the load. Now we will move clockwise at the red circle like this, and now we moving a little bit on the red circle to get the blue circle, and now we move clockwise at the blue circle, which means that we will add series inductor and parallel capacitor. Now at the load we will take this path first. We will move on blue circle clockwise and then on red circle clockwise also, which means that we will add parallel capacitor with series inductor. Thank you for watching our video, and thanks for Professor Abdullah Alzoubi and Engineer Ahmad Fayez.